Hey, what is good, everybody? Welcome back to the channel. In the previous video, I believe we set up our logical device. In today's video, we are going to set up our queue families and our queues. So let me just type this out real quick. Queue families. Essentially, they just are queues, right? So this is what we basically going to be setting up in today's video. Now, I'm not the best explainer, and I'm not gonna pretend and try and give you the definition of what this is. So instead, what I will do is just basically take you to where this is basically kind of explained in a sense. So there are various types of operations a VKQ can support. A queue family just describes a set of queues that have common properties and support the same functionality as advertised in the queue family properties, right? So the following are the queue operations found in queue flag bits. A VKQ graphics bit is used for VK command draw and graphics pipeline commands. So anything that has to do with joint or basically graphics, essentially, we'll use this queue graphics bit, right? And then if you have like compute shaders or anything that needs to do with compute, essentially you'll use this VKQ bit, right? And then it's used for the VK command dispatch and the VK trace raise and compute pipeline related commands. Okay, and then if you have to do any transfers or anything like that, then you'll basically fall under the queue transfer bit, which is used for all transfer commands, right? And you'll see where we're going to use this in a bit in the future. So yeah, just read the documentation and just figure out what is what and what they mean. But I'm still not really the best explainer when it comes to Vulkan. I just read the docs and just figure things out on my own. So yeah, so how do we set this up? Well, if you look at the documentation here, if you just scroll all the way to this page, all the way to this section, you'll notice that they're giving you two families, right? Two queue families, right? So one is at index 0 and the other one is at index 1, right? So they're counting from 0, right? So the first queue family essentially supports the queue flag VKQ transfer bit, right? And it has one VKQ. And then the second queue family at index 1 basically has the following queue flags supported, in this case VKQ graphics bit, compute, and transfer bit, and it has two VKQs, right? 0 and 1. All right, and in your application, in your app or whatever, if you were to follow this diagram here to basically set up your queue families, this is how you would do it, right? You would say you create a create info struct, right, for the device queue, right? And this one is an array that holds two of these. So the first create info in this array essentially points to index 0, which is the one that supports the queue flags transfer bit. And then because it only has one queue, they also just pass in one here. And then the second one here, the second create info, basically points at index 1, which is this queue family. And then this queue family supports two queues, right? It has Q1 and Q2. In this case, they basically define that here, right, to show you that they're using it in that sense. So once you have your queue create infos, all you need to do is essentially feed them to your device creation info struct in the following manner. So this name comes from here, so you just pass in this array down to the PQ create infos, and then the count, well, if you look at it, you basically have an array that holds two of these. So essentially your count should just match how many create queues you're basically creating, right? So in this case, you're creating two of them, and then once you create your device, it'll also create your queues. In this case, it'll create two queues, one for the transfer and one for the graphics bit, I assume, and that's it, right? So that's how you essentially create these. Now, if you look at this diagram, every machine basically supports a variety number of queue families. In this case, it just gave you two. So if you want to check how many queue families your machine supports, all you have to do is, if you properly set up Vulkan, just open up your terminal and just type in Vulkan info, right? And then once you're here, just search for, I don't know, transfer, right? And just keep pressing next until you find this VKQ family properties, or in fact you could have just searched for this instead, right? And then it'll bring you here. And if you look here, right, this is your first queue family, and then this one is your second, and then this one is your third, and then this one is your fourth. And if you look at this diagram here, they only gave you two, So it's possible that your machine only has 2, right? And then on my machine, I have 4. But I'm on Mac, and because I'm on Mac, I know that Vulkan underneath actually just uses metal, right, through a translation layer or something like that, like Molten VK, right? And essentially the reason why the Vulkan API gives you 4 queue families is that on Mac essentially you just have 1 queue family. And my justification for that is, if you look at the queue flags, you'll notice that each queue family that they gave you here literally just supports all the queue flags, right? It has support for the graphics, the compute, and the transfer bit, right? Whereas on this diagram, one of the queue family only supports the transfer bit, and then the other one supports all 3, right? But since we're on Mac, all your queue families literally support all, right? All all of the queue graphics, all of the queue bits, I mean, right? That you can essentially get. So on our implementation of the engine, what I'm going to do is, instead of separating our queue families in a sense that I'm going to be like, at index 1 we'll just use it for the graphics and the presentation, and then on graphics on the queue family 2 we'll just use that one for the transfer. What I'm going to do is I'm just going to use 1 queue family for everything, because at the end of the day, as much as Vulkan gives you 4 to choose from, I believe on Mac it will just, under the hood, just put them all together into 1 queue family anyway. Just correct me if I'm wrong, but that's what I assume is going to happen here. And you'll also notice that each queue family has presentation support, so we do not need to query for whether each queue family supports presentation or not, because if you look here, each and every single one supports it by default, so there's no need for us to query support for this. And the reason why I'm not going to do that is because this engine is built on Mac and it's only going to run on Mac. I'm not planning on porting this to Windows or anything. So the things that we're going to do when implementing our queue families is, I'm going to cheat a little bit and just make it as easy as possible to essentially move away from the queue family creation process. So let's finally write some code. Now, before I write some code, I want to make a few changes here. That's why I put these to-dos. They were not put in the previous video. I just put them here so I can keep track of what I need to do step by step. Okay, so number 1 mistake that I made was here, when I'm calling the pnext, I'm calling the pnext of the feature, the extension feature itself, and I'm pointing it back to itself, so it's just calling itself recursively, I guess. And that is wrong. So what I need to do instead of saying dynamic rendering extension, all I need to do essentially is just say device features.pnext, and then that should then point to the feature that we're enabling here. And notice how I basically put the extension keyword here, and this ends with features. I think what I'm going to do is just remove the keyword extension and just also type feature, and then that will need me to rename everywhere I'm using this, and that's it. So then I can basically just remove this to do. And if you still wonder where the device features is coming from, that we defined up here, and we basically just enabling or selecting the features that we want to ensure are basically supported here. Okay, so now that we fixed that issue, we basically just call the device features in our device extension, and that should then also properly call the dynamic rendering feature as well as part of the features we enabled. So yeah, that's that. So now the second to do is basically just setting up our queues, and I've just went down to basically how to do that. So on Mac, instead of having 2 queue families, we're just going to create 1. So instead of creating an array, we're just going to create 1. So I'm just going to copy this name here, and just underneath the to do, I'm just gonna paste that there. Okay, and we're just gonna fill out this struct. All right, so what I'm gonna call it is, I'm just gonna call it a queue create info. And I apologize if you guys can hear my housemate's voice in the background. I don't know why people are not sleeping at this time. It's actually 2:47 a.m. in the morning, but apparently they still up and they make a noise, so I can't help it. but if you guys can hear them, I do apologize for that. I don't have control of that, and this is the only time I can actually record these videos. So anyway, let's do queue create info, and let's just set out s type to vk structure type. So let's do a vk. Actually, do they have this here? No, they don't. Well, and it's funny that they don't. So does that mean I don't even have to set the s type? I don't know, but I'll just set it for safety purposes. So vk structure type is gonna be device, I think queue create info, like so. Okay, and then after that we're just gonna set, let me see, the family index and the queue count. So what I'm going to do is just say queue create info, and then queue family index, I'm going to set that to 0. And the reason why I'm saying 0 is we're just picking the first queue family that we find, because that will do, right? It supports everything that we need. Okay, so that's what I'm doing here with that 0. And then I'm going to do queue create info dot queue count, and if you look here, it says queue count is actually 1, right? So there is no need for you to go any higher than that because it only supports 1 queue. So you also just have to pass in 1. Maybe on your machine it says 2, so you can basically just select 2 if you want, but I'm gonna say 1 because mine only supports 1. So hey, that's that, right? And then once you're done there, I'm gonna set some properties that they're not setting here, just so that they don't get set to garbage values or something. So I'm gonna set the flags to 0, and then I'm also gonna set the p next to also point to nothing, and then I believe that we are fine. However, I think I'm missing something here, and that is the queue priorities, and I'm just gonna set that to 0. To be honest with you, yeah, I'm just gonna set that to 0. It's crying, it needs a pointer. Can I do this? Nope. So I guess I'll just have to store that in a variable. So I'm gonna do float, I'm gonna do queue priority, and I'm gonna set that to 0 to 1, and then I'm just gonna copy this name and just paste it in here, and just take the address of that, and I think that should fix it, and it does. So this right here will create our first queue family, and we only need 1 because it supports everything that we need it to support. So that's what we are going to settle for here. So now I can uncomment these because I actually commented them in the previous video. So the queue create info just points to this guy, so I'm just gonna paste this here and take the reference of that. And then for the count, we are just going to say it's 1, because we're only creating 1 queue family, right? 1 queue essentially. So I think with that being set, we are good to go. So next is, I still have this fix me, but I'm gonna leave it there for now, because yeah, it's fine for now, I guess. And now we're gonna move on to these, right? And the reason why I want to set these up right now and here is because if you look, when we're creating a logical device, we queried for dynamic rendering, and dynamic rendering essentially in its own respect requires us to query the function function pointers for the VK begin rendering and the VK end rendering. So essentially we need to basically query for this using a proc address, and I think I actually found how to do that in the documentation, and that's what I'm going to do. So yeah, that's what I'm going to do, but I need somewhere to store this globally so we can actually access this from anywhere in the Vulkan implementation. So what I'm going to do is I'm going to go down to my Vulkan defines, and I'm going to stub this in the Vulkan context. So where is that Vulkan device? So I'm just going to copy this and go down to our defines, and I'm going to paste it, and I guess I can remove this like so, and we're good, right? And that's it essentially. So next what I can do is just come back here, and all I can do now is just say context, and I don't have context. So I guess it's probably a good idea to refactor this signature, okay? Because now it's gonna get long, right? So let's go to the device.h, and instead of passing in the physical device and the logical device separately, normally I didn't really want to pass in the whole context, but I guess I should now. So what I'm gonna do is just say Vulkan context and set this to context like this, okay? And then I'm gonna come back, well, before that, let's just copy this real quick. Then I'm gonna come back to the implementation file and just replace this whole thing with Vulkan context like so. Now you'll notice that we have some issues to fix, which is no biggie. All we have to do is just say context like so, and because it's a pointer, this is how you'll fix that. And now this goes down like so. So I'm just gonna copy this whole thing and just replace everywhere where I'm using that as is. And then for this one, I can just multi-select and then do context like so, and then just replace these with actual dots, and then the same thing here as well. So I'm gonna do this like so. Beautiful. And then down here we don't longer have the logical device, so we're gonna fix that as well. And here it should be like this for the GPU, and for the logical device, all you do is just say context slash logical device. Well, not a slash, but that arrow, and just pass in the address for that. And if you did everything correctly, you shouldn't have any errors. So this will then allow us to simply say context, and we can say begin rendering is equals to, let's just look at the documentation here, begin rendering this whole thing. So I'm not gonna type that, I'm just gonna copy paste it, and I'm gonna paste it in like so. And then it wants the instance, so that is in our context, so we'll just pass in the instance like so, and we're done. And then the other part is for the VK command and rendering. So all we do next is just say context VK command and rendering, and for that I'm simply just going to yank this out of here, just copy that and put it in here, and that's about it. And for the context, we just for the instance, we just pass it in like so, and we are simply done here. And we can just get rid of this to do and just replace this with dynamic rendering, right? Purposes. Good. In case you were wondering, what is this for? But anyway, now that we're done with that, I think we can basically test to see if our queue setup actually works. So what I'm gonna do is I'm just gonna build the project. And of course we have errors, and of course I think it has to do with the signature, and yes it does. So instead of passing in all these in here, we just pass in the context like so, and then just save that and rerun, and boom, it built successfully. And I'm just gonna double check that it did, and yes it did. So now we can just simply run the app, and everything else should still work as should be. So logical device got created, meaning that this bit actually works, and we reached the end of it. So yeah, that's it for the Queue family creation. I skipped a couple of things that normally you would do, but because I'm on Mac and I know that essentially everything just makes use of the one family, Queue family, yeah, there was no need for us to query the amount of Queue families, get their properties and see what they support. You could do that, however, if you want to make sure that it's cross-platform, but I know this video or this series essentially is just based on Mac, and it will just remain Mac specific. So this is the way that I do it. It's pretty easy, it's pretty simple, and if you have any issues in the future, we could just always come back here and then just create another Queue family and then make use of that as the documentation might want you to use it as, like this, right? So yeah, but anyway, there is no need for that on my end, and I'll just keep it this way. So we are actually done here. So in the next video, let me see what we're gonna do in the next video. In the next video, we are going to set up the surface, and that should be pretty straightforward as well. And then once we have our surface, we can finally come back, and I think we will do the swap chain. All right, and then yeah, and once we get to the swap chain, that's where things sort of get interesting. So yeah, definitely stay tuned for that. Cheers. If you guys enjoyed this video, definitely hit that like, subscribe button, and I'll see you guys on the next one. Cheers for the second time.